VNE stands for Virtual Network Environment, but I guess you already know that. But what does it really mean? The ideal lab environment to test headnet scenario will look like this one. I said would, because you'll most likely have to simplify this environment. Why? Because such a lab environment would be extremely complex to set up and use, and of course extremely expensive. So you probably went for less lab infrastructure and more test equipment. Why does it not solve the issue? It's highly inaccurate. So what's the solution? Yes, it's VNE. VNE generates the 3LT interfering cell on the link between the tested cell and the UE. It's a highly accurate virtual environment, it's cost-effective and extremely easy to manage, with the test bed reduced to the minimal, and with the automatic time synchronization between the desired cells and the emulated ones. How? With the internal LT receiver integrated inside the RNX. It demodulates the signal coming from the base station under test and takes the timing information out of it. So I guess you want to know how this works. So let's try to create an interfering eNodeB on Director 3, the software that controls both the RNX and VNE. On Director 3, we will start by creating our own LT base station and then we'll play it back. So to create the LT base station, we have two options. We can modify an existing LT base station or create a new one. First, we can configure the basic parameters of the cell, such as the cell ID, the bandwidth, and the number of antenna, and parameters such as the extended cycle prefix. Once this is done, we can go deeper into the configuration by setting the PDHCH parameters. Transmission modes 3 and 4 are available today, as well as all the ABS patterns from the 3GPP. As you see, we can immediately see the results on the screen by looking at the frame structure. It couldn't be easier. What else? We can set the traffic loading, the rank proportion, and play with the control format indicator and select from 1 to 3 of the M symbols. An NNet environment would not be accurate without fading condition between each interfering cells and the UE. This is why we can directly select one of the following fading models, play with the correlation matrix, and adjust the channel Doppler. In addition to that, we can specify values for the power allocation parameters, rho A, rho B, and sigma. When we are done, we just hit save, and we'll be able to recall it for later use. So let's remember our test case. We have one cell connected to the RNX and one UE. And on top of that, we want to add 3 interfering cells. We've just created one, so let's see how we can map it to our physical link. We will move to the Link tab of Director 3 and select our physical link. So for this example, we'll take a 2x2 APA model, but it could have been any other fading models. On the right panel, we will go to the interesting section. We can pick any of the interferers we've created earlier. This can be a standard base station interferer or one we just created by our own. As you know, for each physical link, we can enable 3 interferers. So we'll select the first one and then a second one. And instead of having the same time frequency domain as the physical cell, we will move it a bit. We have a complete freedom of each interferer to move them dynamically when we create the test case. Once we've set up our link, playback is extremely easy. In the Playback tab, I'll select the test bed and the test case, and I'll just hit Start. As soon as I hit Start, the internal sync receiver within the RNX will time synchronize with the desired cell and then add the interferer on top. It couldn't be easier to create your next headnet test case.